السلام عليكم ورحمة الله وبركاته. شكرا لانضمامكم لليوم الثالث من برنامج المدرسة الأساسية، والآن مع الجلسة الثانية لهذا اليوم سيقدمنا الأستاذ الدكتور نادر البزري، وهو عميد كلية الآداب والعلوم الإنسانية والاجتماعية بجامعة الشارقة، بالإضافة إلى كونه أستاذ في قسم التاريخ والحضارة الإسلامية. حصل الدكتور نادر على درجة الدكتوراه من كلية الدراسات العليا في المدرسة الجديدة للبحوث الاجتماعية في نيويورك، وكذلك درجة الماجستير في الهندسة المعمارية من كلية الدراسات العليا للتصميم في جامعة هارفارد. تتضمن اهتماماته البحثية تاريخ العلوم والفلسفة العربية، بالإضافة إلى نظريات العمارة وكذلك علم الظواهر. حضرت اليوم بعنوان فلسفة العلوم في العرب والأوروبيين.
السلام عليكم. It gives me pleasure to take part in this winter school. I'm going to deliver my talk in English, but there'll be some elements of it that are Arabic. Yeah, it's falling. Shall I put it? It's falling from here. I'll put it on the cravat. Can they hear me now? It might fall again. Let's try it. Over here. It's not falling. Hopefully not. Yeah. Oh, it's falling. So let us try inside the pocket. Oh, it's falling. Okay. This one. Yeah. Yeah. Can they hear? Okay. So I remove it then. All right. Very good. I'll leave it on the table. Yeah. So I wasn't sure if I go with English or Arabic. I'm more than happy to do it both ways, but I felt for a wider audience, given that there are many who are joining us online, perhaps it might be befitting for this occasion to deliver it in English. And then, there'll be some dispersed engagements with it in Arabic, as the material evidently is suggesting itself to be dealt with through classical Arabic. And this could be part of our questions and answers and commentary session after I deliver the talk. Evidently, in the span of a session like this one, it is very hard to account for the full breadth of the engagements with the sciences within the context of the Arabic and Islamic civilizations, given that they had various phases in terms of the unfolding of science within the context of these civilizations and cultures. And therefore, I wanted just to give you a sort of a broad aperçu over elements that not only relate to the history of science, but also to the development of particular philosophical attitudes or attitudes that come from epistemology, meaning, قضايا معرفية, in how you engage with the exact sciences in the classical period and how you integrate them within the broader outlook you have on reality. How do we understand the world? How do we account for objects? In what kind of reliable format can knowledge be handled? And how science fits within that kind of framework that is epistemic in character. So that's why I took the orientation towards a philosophy of science in the Arabic traditions, given that I don't want just to offer a historical aperçu over the engagement with the sciences, but also to give an understanding of how this reflects their approach to reality, to understanding the nature of knowledge itself and how it is accomplished in relationship to senses and other devices and frameworks that allow for veridical knowledge. So knowledge that is ascertained or subjected to some form of experimentation or testing. Now, in order to engage with this, we need a little bit of a historical context, and I guess most of you are exposed to it in different forms, but it doesn't do harm to just give a sort of a broad context before I zoom in on two traditions in handling the sciences within the classical Arabic Islamic civilization. Yeah, all right, okay. Before we look at the Arabic tradition itself, we have to understand the context in which it begins to flourish. And we should realize that ultimately the lands that stretch over the Levant, Bilad al-Sham, over Mesopotamia, Bilad al-Rafidain, North Africa, in particular Egypt, would have been part of what we normally could describe as being the Hellenistic diaspora. So it is a Greek world that happens after the invasion of Alexander, the conquest. And ultimately, there's a flourishing of various centers of learning across this land. That builds on civilizations that predate also the coming of the armies of the Greeks under Alexander's conquest. And one standing example are cities like Alexandria itself, which would have produced figures such as Euclid engagement with geometry or Ptolemy's engagement with astronomy. We could go even to Jordan, Nicomachus of Jarash, again, a contribution to fields that relate to arithmetic. And there are lots of other depositories of knowledge, such as the ones that were in Harran, in the northern parts of Mesopotamia. And part of this is also due to later developments that relate to the Roman era, and in particular to a transition to the Christian age and the closure of Plato's academy in the 6th century, which necessitated that the philosophers of the Neoplatonic tradition, so the followers of a tradition in philosophy, in the Greek tradition in philosophy that follow Plato, but that have been also impacted by the tradition of Aristotle and developed a new form of commentary on Plato that is influenced by, again, an additional figure called Plotinus, Aflatun. And they constituted a academy in Athens that was still continuing with what we might, quote unquote, call pagan philosophy. So it is not religiously oriented, even though many of its elements were very useful for the Christian theological thinking. But nonetheless, it was closed. Those Neoplatonist philosophers escape. They take refuge at the beginning in Persia, but some of the narrations, historiography narrations, suggest that they might have settled in Harran. So even in the context of not focusing on the actual philosophers settling in Harran, there's also a depository of knowledge that is developing in that context in assimilating ancient Greek knowledge in the context of a place like Mesopotamia, or what we currently call Iraq, right? Bilad al-Rafidain. So with the coming of Islam to these diyar, to these lands, the initial phases were also integrating elements that go beyond the intellectual history to material culture. There's great evidence in architecture that, when we look at the Umayyad architecture itself, it was taken, in a sort of a engagement at certain level with Roman architecture. So there are many layers of the Greco-Roman world that remain even within the courts. So even at the start of the Umayyad dynasty, even within the court itself, Greek tongue was still useful for conducting the bureaucratic affairs of the court itself. So that's the kind of milieu in which we are seeing gradually the unfolding of schools of thought that belong to what we might call the Arabic and Islamic culture, and inheriting through that a Greco-Roman world with its cosmology, outlook on the universe, outlook on reality. One of the outlooks that is very fundamental for any scientist in the period that is under the Umayyad and eventually under the Abbasids is the assimilation of a cosmology that is Aristotelian. So when they look at the structure of the their understanding of the universe, they're thinking of it through the agency of the cosmology of Aristotle, as also mediated via a more advanced version of application of geometry to astronomy in the context of Ptolemy. So in a sense, it is a Hellenistic view of the structure of the universe that becomes the basis upon which Arabic and Muslim astronomers or polymath in general would engage in understanding the structure of the cosmos and how to think of it in relationship to a geocentric model. So the Earth is the center of this universe, and the implications that this has on understanding how this affects the seasons, how this affects our temperament, even as individuals, because this is coupled with a tradition that comes from the Greco-Roman take on medicine, that is Hippocratic and Galenic. So in Arabic, Jalinos, yeah. And it takes into account that there is an effect that comes from the astral or celestial bodies that can have implications on our temperament. Our temperament itself is correlated with bodily fluids that if they change in their harmonic proportions, they can alter the mood. We are affected by things that could relate to season, to heat, to dryness, to coldness. And these affect certain easiness in our body, comfort or discomfort that reflects on our psychological predispositions. And this psychological predisposition itself feeds back in what is called psychosomatic way onto affecting the body itself. So sometimes the mood itself can affect the body, and the body in return is feeding back into the mood. And this is not only related to my embodiment as an individual or in relationship to my dwelling on the earth, but also it relates to the entirety of the structure of this cosmos that affects in the various dispositions of the celestial bodies, particular impressions that come onto us that change the mood and change even the effect on the body. So that kind of worldview that starts with a cosmic aspect and reaches inside our veins is inherited in the context of the Arabic traditions that start to evolve in response to the Greek corpus. And the Greek corpus has multiple figures in it, but what stands mainly in that regard are figures like Plato, Aflaton, Aristotle, known sometimes more as Aristoteles, how they call it, but later on Aristo, Aflutine, Plotinus, Euclides, Euclid, Bathlamios, Ptolemy, Jalinos, Galen, right? And I highlighted few elements of that Greek corpus that is leaving its impress on these early commentators. Comes the Abbasid period, particularly the period of Harun Rashid is fundamental. There are some beautiful, we could look at anecdotes of his engagement with Charlemagne and trying to impress Charlemagne, sending Abu al-Abbas, the elephant, but also with a water clock, mechanics to show the counterparts, imperial counterparts, the greatness of the realm. But this is the manifestation in material culture, but there is something much deeper that is taking place. It is now a serious engagement with the Greco-Roman corpus, and particularly the Greek corpus in philosophy and all the branches of the sciences that could have been accessed at the time through depositories of knowledge in lands such as, I said, Bilad al-Rafidain, Bilad al-Sham, and Diyaru Misr, right, Egypt. So that's when we have this phase that normally scholars describe as the phase of the great transmission and translation movement. And it is a phase that engages with translations, sometimes not directly from Greek into Arabic, but from Greek into Syriac into Arabic, and at times from Syriac into Arabic. So there is an intervention of the Syriac language as being fundamental for preservation of the ancient knowledge that is coming from the Greek world, and now taken as being the basis upon which Muslim scholars are going to build their cosmology, they are going to engage with their metaphysics, are going to engage with their reflections on the nature of the soul, yeah, and nafs, and their engagement with at-tib, medicine. Now, that engagement early on wasn't a mere transmission. Already there was a critical edge to it. So in a sense, it is coming at times from internal conditions of looking at particular disciplines in mathematics and astronomy and mechanics that suggest solutions or reformulation of old problems in new ways. So it is an impetus that is based on knowledge rather than just response that is cultural. But at other levels, it is coming also from everydayness, from the needs of culture and society to develop new branches of science, particularly mathematics, as an example, that could answer to more complex forms of social relations that relate to the impress also of Islam from a religious perspective on how to organize the affairs of the community, right? يعني توضيب أوضاع الجماعة. So this is where, for instance, if we look at Khwarizmi, the treatise itself is starting not immediately with engagement with mathematical entities or problems, but it is looking at particular practical issues that relate to irrigation, distribution of proper distribution of issues of irrigation, division of land for inheritance purposes, division of assets also for inheritance purposes, disputes over contracts, how can they be settled in manners that are perfected beyond the mere arithmetic calculation. And this necessitated, right, developing this sub-branch in mathematics, which is al-jabr wal-muqabala, right, algebra. So the basis is engaging with the nature of how can I push the science of numbers to its fullest possibilities to fulfill new problems that are arising from the practical aspects of everydayness, and realizing that what I have tools in terms of my science of numbers, calculation, requires development of new branches that allow for calculative approaches that those who came before in the Greek tradition were unable to come up with the right solutions for them. So here, from practical conditions, there is a development in the mathematics into a new branch that is taking into account the needs of the society against the background of aspects or directives that are coming from an inclination in thinking that is fiqh-based, right? That is coming from religious law and its applications. So this is one of the examples. Another example is the circle that develops around Al-Kindi. It is full of individuals that are engaging in various branches of knowledge, that each of them is developing a new sub-branch within the field that they're dealing with. Whether it is something like trigonometry, simply the science that studies, the structure of muthallathat, right, triangles, and trying to figure out of it new ways that change the mind frame in which we deal with mathematical objects. The Greek mind, in terms of philosophical inclination, would have preferred to consider the geometric entity as being static. It is invariable, it is not subject to motion. What is subject to motion or variation belongs to the realm of physics, to the realm of tabi'ah. And this is a model that comes from an Platonic tradition from one side and Aristotelian tradition from the other side. Yet some mathematicians in the 9th century within the Arabic milieu are now subjecting the mathematical entities to some form of transformation, therefore putting motion onto the mathematical entity in a way that they don't take the rule that is coming to them from the Greek corpus as being a principle that should not be broken. It's not axiomatic. So this is another example of how it is starting to unfold in a direction that is not simply commentary and translation, but expansion, critique, raising questions about what they inherited. And one of the main problems that they inherited is the kind of observations that they have of the celestial bodies and trying to correlate them with the model, mathematical model in astronomy that is coming from Ptolemy. And there is a problem here. I don't want to enter into its details. One of the problems is the quant problem. So they don't see matching between what observation is yielding and what the geometric modeling is giving them. And yet for the entirety of the system of thinking about the cosmos, they cannot do away with the geometrical modeling, but they need to fiddle a little bit with it. By fiddling a bit with it, they need to develop more complex forms of astronomy thinking that takes into account the application of motion to geometric entities. Because ultimately, when you're describing the cosmos through geometric means, you're describing a system of motion, and you're using geometry to describe a system that is kinematic. So it is subject to kinesis, subject to haraka. And out of that, you need to understand the geometric structure of the motion, which doesn't correlate with what observation is yielding. This necessitates a reconsideration of the model, which starts with series of commentaries that are critical of Ptolemy's model without doing away with it. And one of the main treatises that stands, has a clear-cut title to that, is Ash-Shukuk ala Bitlamyos, which is, doubts concerning Ptolemy, which is drafted by Al-Hasan ibn al-Haytham, a figure that I'm going to focus on. And this culminates series of commentaries that are critical of Ptolemy's model that culminate later on at the hands of Nasiruddin al-Tusi into a much more advanced way of dealing with this model without moving away from it. So when we talk about classical Arabic sciences, we remain within the sphere of the Ptolemaic model, but feeling totally at unease with the way it describes the structure of the cosmos. Now, I want to go into something more concrete. I spoke with details that are very vast over 2.5 centuries at least of developments. But the basic idea is there's a Hellenistic Greco-Roman corpus of science inherited, first transmitted, then subjected to critical analysis. Out of it, new sub-branches are evolving in the sciences, and continual refinement of this system of multiple branches in science. And the multiple branches are across the various fields of mathematics, what is called natural philosophy, physics, touching upon the anima treatises or treatises on an-nafs, kitab al-nafs, treatises in medicine, and you name it. I want to stop at first with an attitude that is coming from culture rather than from specialists. Because if I speak about Khwarizmi or Banu Musa or Thabit ibn Qurra or Ibrahim ibn Sinan or Al-Kindi or Al-Farabi, I'm talking about polymath. These are at the forefront of their fields. Some of them are pure mathematicians, some are polymathic. So they do mathematics, they do astronomy, they do logic, they write on commentary on the understanding of the nature of the soul, and they write metaphysics. But some are specialized. Comes here a group called Ikhwan al-Safa, right? And they developed a series of epistles or rasail, right? 52. Sometimes we think possibly now that they are 50 rather than 52, but that's a detail for scholars to sink into and build their career out of disputes between each other over, what constitutes the corpus or not. We don't know exactly their identity. Again, we fight between each other over determining who really wrote it. And when we don't understand exactly who they were, we don't know how to place them historically, but roughly we could say in the second half of the 10th century, right? So around the second half of the 10th century, this is a فرقة من فرق المسلمين نشطت واستوطنت في البصرة, right? It's a group of learned individuals, not specialists, who are operating in Basra, and some think that they might have had a branch of their group in Baghdad. There are suggestions that they are not only men, that they might have in their majalis, sayyidat, right, women. And they are coming from various walks of life. That's the general feel that we get around this group. So it is a learned society of individuals that gathers in regular sessions, majalis, seminars of sorts, and the rasail are some kind of didactic material for education, material almost like what we might use in a introductory course as a textbook. So they're not the most sophisticated in terms of the content, because there are people in their milieu and those who came before them who would have been quite advanced experts, whether in arithmetic, geometry, astronomy, music, geography, logic, treatises on minerals, writings on plants, a magnificent fable that is addressed to the condition of the animals. So for instance, their fable is so beautiful for our own age today in terms of ecology. There's a whole project I'm involved in of editing the manuscripts of the Rasail al-Safa and translating them. And we had a volume, almost 500 pages. The title is The Case of the Animals Before the King of the Jinn. So the animals are so, and we're talking about 1,000 years ago, if not more, right? And think of these people as not polymath, not experts in their fields, but learned individuals, intellectuals in Basra that are telling us, look, the humans are terrible in what they do to the environment, what they do to animals, let alone to what they do to each other. And the only way we could settle it is that we need an authority that exceeds the human nature, because it seems that the human nature must be bent on a suit more than it affirming, you know, some aspect of promoting goodness. So the fable goes with the idea of taking the human beings to the court of the king of the jinn, and the animals are taking us to a court case. There's an early edition of this text that ends up with giving us a sort of just on the edge saying the humans, you know, you've really misbehaved, but the king of the jinn lets us go in somehow, saying that you are acquitted from this case. But after we looked at other manuscripts, we discovered that the case is still open. It never closed. 1,000 years ago, we're still called upon to change our habits, to change something in our nature that accords with all that we could have from all nations. And this is where this group brings to the fore an idea that is so beautiful, that in each nation, in each sect, in each religion, in each society, in each culture, there is an element to it that is most perfected. And should it manifest that element in its totality, humanity can save itself on earth and save all sentient beings and the environment. And that's the last kind of, you know, the insanul kamil to their mind cannot come from one particular faction, one particular people, one particular culture. It has to be global. And this also gives us an understanding of their attitude towards the sciences of the ancients. And they took to heart all that came to them from the Hellenistic corpus, besides relying very much, and their rasail are full of references to the Quran al-Kareem, to the ahadith, and to aqwal al-a'imma. And also they try to integrate many of the hikam, right? The wisdom literature from India, from Persia, from sources that that relate to the Sabaeans, you know, various cultures, and also emphasizing the multi-religious, multi-ethnic character of the society that they are in. Now, what is interesting about their engagement with the sciences is that they have a thread that ties the whole system together, and it is usually described as being part of what is called Neo-Pythagorean tradition, Pythagoras, right? Pythagoras. And the Pythagorean tradition at its heart takes mathematics as the entrance or the entry point towards understanding reality, towards understanding the structure of what we take to be nature, whether it is nature in its physical manifestation in minerals, plants, and animal life, or nature also as it manifests itself through intellective aspects, emotional attributes that relate to a human sentience, a human cognition. And in their mind, the whole understanding of reality cannot happen unless we look at it through the agency of understanding the relationship between numbers. And numbers themselves are all reducible to reiterations of the number one. So in a sense, the basis for understanding the entire reality is how from the one issues the many, the manifold, and how it turns into complex structures as numerical systems that become a basis for describing geometric entities. So from the point, the one is a point that is without magnitude, and we have another point that is a demarcation in place. Between them, there is a distance that describes what is a line. A line is without a width. 3 points describe a triangle. And then out of the triangle, you flip it into becoming a series of triangles that describe a solid like the form of a pyramid. And that pyramid in the Pythagorean tradition would become a symbol for the corpuscles, or almost something like as minuscule as an atom, out of which is constituted an element that is like fire. And then out of this, they start to look at more complex shapes until they disclose what to their mind relates to corpuscular entities that are invisible to the eye, but they are geometric structures. When you put them together, they constitute the 4 elements, right? Fire, earth, water, and air. And out of these, you start to see the manifestations on earth of a combination of these 4 elements that manifest various objects or entities that have physical properties that give the semblance of resistance to our hands. And so ultimately, our cells and all that is constituted in the world is reduced to geometric corpuscular bodies that in themselves are reducible to triangles, triangles reducible to lines, lines being entities without width, lines being a distance between 2 points, points being demarcations in a place that don't have magnitude. So we are living in what? Matrix, right? Something like the matrix. There's 1, and between 1 and 1, there is the disappearance of the 1 unless it is manifested at a certain level between A and B, or else that between A and B, if there is a demarcation of a C, there is a 1 and a 0 disappearance of the demarcation, and it's reappears. So 1 zeros 1 zeros zeros 1 zeros 1, you name it. And this tradition is coming from Pythagorean legacy that connects to a book that is fundamental in the Arabic tradition called At-Timawos. And this is the name of an astronomer that Plato evokes. And the title of the book in the Greek is Timaeus, right? Timaeus. And in Arabic, At-Timawos. So it's not only that they are a group of intellectuals, they have a structure to understanding reality that is looking at the physical world as being mathematically structured. And the only way I could understand reality is through mathematics. And out of understanding reality through mathematics, I disclose that there is a fictional character to the world that we live in. That it is not as real as the world that exists behind it and sustains it and grounds it. We are belonging to a realm that has the properties of what is more akin to a mere appearance rather than a reality that yields a truth. For me to disclose the truth of this world, I have to train in the mathematical disciplines. And that's why they have a treatise on arithmetic, a treatise on geometry, a treatise on astronomy, a treatise on music, because music deals with the harmonics that are in the celestial spheres. There's music in the universe to their mind. They even can, through their system, suggests that it could correspond even with the musical instruments that are used on Earth. And beyond that, they train into the arts of proportion. I discovered recently that some of their use of harmonics were used in Madinatul Zahra in Andalus, in the architecture. So the treatise started to spread beyond the domain of Biladul Rafidain or Iraq. And that gives you just an idea of the cultural assimilation of scientific knowledge and bending it in a way that fits a particular worldview that is now emerging in the Muslim Arabic milieu, such as Basra in the second half of the 10th century, that has originality in every page to it. And yet, within its folds, you have the Greek corpus, the Roman corpus, Indian wisdom, besides their reliance pretty much on their understanding of the religious faith in appealing to the Quran and to the Sunnah, and also to the Hadith and to Aqwalul A'imma. So now I want to move away from them. And this is the kind of manuscripts that, for instance, we start with when we are doing editing. This is a title page for epistle 6 في النسب العددية والهندسية والتأليفية, right? تأليفية is harmonics. And in there, they have a system that is remarkable because it could be used for architectural design. And through it, they have also an understanding of the structure of the corpus of the human being, that ultimately the proportions are entirely embedded within us. So what is so telling in this is that they have what is called the Vitruvian Man in it. So they are appealing to a Roman tradition. Vitruvian Man, normally on Google, you see it as Da Vinci Man. It's not. It goes to Vitruvius. It goes to the Roman legacy. And it's a Roman legacy that through the structure, you know that figure that stands like that? Yeah. There's symmetry. Yeah, symmetry. There's something quite bizarre. Like when I stretch my hands like this and I stand here and you take this height, I'm standing in a square. And these, if I just lift them a little bit, I'm standing in a circle. And the center of the circle is in my navel. The structure of harmonics is in my body. And they take it and turn it into harmonics for designing facades of buildings. Okay, I'm trained as an architect. I'm looking around me and I see sometimes big capitals and whatever. They don't have harmonics. It's an architect that just, cut and paste, not doing the right job, right? And the harmonics are embedded in lots of entities in nature. You get out of them golden ratios, you get out of them certain configurations that to our eyes become so elegant, we feel comfortable with, because they resonate with a particular relationship that exists in all the ambient environment in which we are embedded, including the very structure of our body. So these people are so concerned even with this aspect of the mathematics that is at the basis of the structure of my body itself, that stretches out into the structure of what they saw as being an ordered universe, an ordered cosmos. Now I want to move to something more complex. So I'm going bit by bit, from the generalities to the treatise that is for, intellectuals in the Basra in the middle of the 10th century who are highly learned, to going now zooming into something that I see in it proper philosophy of science. Not only science, but a philosophy of science. And this is Kitab al-Manazir al-Hasan ibn al-Haytham, right? The book of optics of Al-Hasan ibn al-Haytham, known in Latin as Al-Hazm, right? Born around 965 in Basra, died possibly 1040 in Cairo. We could have a beautiful film just about what we know possibly about his biography. He excelled in Basra. If it is possibly that the Ikhwan al-Safa were active around 960 to 980, then he would have been exposed to them at least throughout his teenage years as a milieu in Basra that is very much active, not in the point of being engaged with the sciences at the level of scholars only, but it is now becoming a social phenomenon of culture. It is majalis in the city itself. There are lots of issues around it because they are still a secretive society, but nonetheless, they are meeting to discuss the science of their age. So Ibn al-Haytham has this treatise that is composed of 7 maqalat, 7 volumes or 7 books, 7 books. Books 1 to 3 deal with direct vision, yeah, and books 4 to 6 deal with the reflection of light. It is a science in the Greek tradition called catoptrics, and then the treatise 7 deals with dioptrics, the refraction of light. So reflection of light in in'ikas al-daw, right? Refraction of light in in'itaf al-daw. Sometimes he uses inkisar, but in most contexts he's using in'itaf. Now, he doesn't use the term nur. He talks about daw. So he's talking about physical light, physical light. Now, before he sets his treatise, in the period then that he develops his early career as an architect, involved mainly with constructions that could relate to hydraulics. So things that relate to building dams, controlling water channeling, aspects of surveying. And in surveying, he would have used also the algebra of Khwarizmi. So he excels in the applied aspects of mathematics in the context of serving things that relate to material culture in general. There's a dispute between 2 people that I have the utmost respect for over whether there are 2 Ibn al-Haytham or 1, because there are certain treatises that are attributed to an Ibn al-Haytham that would have written a work that relates to theology. But in general, in the development of the figure of Ibn al-Haytham or al-Hasan Ibn al-Haytham, because there is the term Muhammad, but it could be Kenyan. So there's a dispute between 2 grand masters of the art over the biography. But let us say that he is someone who is known as being polymathic in the arts of applying the sciences of mechanics and of mathematics, all the branches of mathematics, to solving practical problems that relate to building construction that can be used not only as architecture and dwelling, but also for aspects that relate to constructing dams or channels or bridges, you name it. So his reputation excels. The story tells us that Al-Hakim bi Amrillah, the Fatimid Caliph in Cairo, hears of the news of this remarkable figure and thinks that he could have a sort of a brain drain phenomenon to snatch him from under the Buyids and Abbasids in Basra, and to bring him to Cairo to construct a dam or water barrier to control the ebb and flow of the Nile River. And Ibn al-Haytham does a surveying of the upper Nile and eventually comes to the realization that this project cannot be completed, cannot be done. Neither technology nor the know-how that he has or his contemporaries have could achieve it. And I guess perhaps history proved the same story, because even with the great mastery of Egyptian engineering, it took until the era of Jamal Abdel Nasser to be able to construct the dam. And it needed perhaps also technological support from entities, even the Soviets at the time perhaps also helped. So it gives us an idea that Ibn al-Haytham was an honest assessor of his capabilities and the capabilities of his age in meeting the demands of building a water barrier to control the Nile. Now, we don't know when he wrote the treatise Kitab al-Manazir, but most likely after the disappearance of Al-Hakim bi Amrillah, or his death, or perhaps his assassination by Sitt al-Mulk, I don't know. She's the regent. Maybe Ibn al-Haytham started to become more active under Sitt al-Mulk, because during the era of Al-Hakim bi-Amrillah, he was scared that his patron will have a retribution over his failure to construct or to devise a project for controlling the Nile. And the Hakim bi-Amrillah was known to be capricious, so Ibn Haytham feigned madness. So he acted as if he was mad. Maybe he resurfaced around the era of Sitt al-Mulk, so after 1021, and wrote the treatise in that period. But what's so important about the treatise? He has a consideration of the role of observation or the senses in the acquisition of knowledge. So we rely on our senses in terms of acquiring knowledge in everydayness. You're hearing me now, you're taking it on face value somehow that I've done something that relates to these fields. So most of you are accepting what I'm saying as having a veridical character to it. So my propositions have a truth value to them that yields to you saying these propositions or sentences are true. The reality is far more complex, because there might be someone else who is my colleague who fights with me over a date or over a statement that would say, no, not true, half true, bit false, whatever, right? But I'm standing here, you're seeing me, you're hearing me, and you're accepting everything that is presenting itself to you in this direct ambient environment. You're doing this through your senses, right? Through your corpulence, your bodily presence in this space. Most of you are not seeing the back of the room. I could say that there is something happening now, you know, the gentleman at the end, I don't know, is waving his hand. He's not, but, you know, I could say something like that. I could say a few things that, you know, it is dark now outside the space because now the time is nearing the time of sunset. But can you accept my proposition that it is sunsetting, you know, already? We can't, okay? So I'm dealing with the senses. How do I look at these sense data and think of them as being reliable enough for me to derive out of them a statement about the world that has truth value, and truth value that is veridical, not, you know, falsity. But also falsity is important, because if I falsify a particular proposition, at least I know from now on that particular proposition has a false character to it. I discard it as a reliable knowledge. So this is rudiments of beginning of philosophizing about how tools that relate to science can help me control the conditions under which I could still rely on my senses, right? So I'm not doing away totally with the senses, but I need to set conditions under which these senses can be reliable. Now, this is a book on optics. It's not a book on music or auditory aspects, nor is it about olfaction. He's not a perfumist, nor is he an alchemist, nor is he someone very much interested in culinary taste, so that he focuses on taste, right? He might have been interested in mechanics at certain part of his life. So partly, you know, the aspects that relate to weight and aspects that relate to touch might have concerned him. But here he's concerned with the most fundamental of aspects that relate to the senses, which is vision. Observational data, right? How can I deal with observations in a way that ensures that what I'm observing yields information that is reliable? First thing, I need to understand the nature of vision itself. There was two sets of theories that he inherited, not only himself, but Kindi wrote also a treatise on that, and those who came before them, like Ibn Sahl, dealt with these traditions in optics. But two traditions mainly come from the mathematicians, one side, and the natural philosophers, or أصحاب العلم الطبيعي أو أهل العلم الطبيعي, right? أو الطبيعيون, right? أصحاب التعليم, the mathematicians, would be from the lineage of the Euclidean Ptolemaic tradition. أصحاب natural philosophy, physics would come from which tradition in the Greek corpus? Who is the main writer of the physics the book of physics? Aristotle, right? So these are the two mains, but there's also the traditions that come from Galen. But the two main ones state, the mathematicians would state an extra mission theory. So I see things because there is a set of rays of light that are emitted coming out from my eyes that go into the outer environment. They issue forth when there is illumination in the outer environment. Why? Because these lights have the character of being a subtle fire. Yeah, fire that is non-consuming, it doesn't burn. And it is coming out into the illuminated environment because like meets like. الشبيه يلتقي بشبيه. So they issue forth. Given that they are coming from the center of the eye and going through an aperture that is a circle, what do you think they would look like? Imagine it, right? There's a center and there's a circle. So if you extend it, it is what? A cone, right? Two cones. Now we don't see them because this is subtle light that is coming out and the illumination absorbs it. What is telling for Ibn al-Haytham is not the physical reality of the light, but what is important for him is a geometric structure. He has it now from the mathematicians. Now I have a cone. I go to the Aristotelian tradition, or the tradition that comes from what is called physics or physis or at-tabi'a. Yeah, it tells us that I see things because of the. So I'm looking at things. In the Aristotelian tradition, we are composites of matter and form, shape, form. Now we are in the age of manipulating form. You know, our form is disseminated all over Instagram, whatever, right? So we are issuing forms. So now between me and the gentleman here, this form is moving. Okay? His matter is there, but his form is moving with the light. And I'm standing here. Look at his form. Okay. How is it entering into my eye? I see because I abstract the form from its matter in such a way that the form enters into the eye when the ambient environment is illuminated and acts as a transmitter of these forms from the object of vision to the eye. But evidently, you know, take this, the form, and I'm putting it near my eye. How is it entering? The theory doesn't give me yet an answer as to how it enters. Now, if I take the cone system, right, the geometric structure, and I put it here, and I say rather than rays of light are coming out from my eyes, I say they are coming in. Look at this. So the form within the cone enter. All right. So now the actual explanation of how vision occurs is that from the object of vision, there are rays of light that are issuing in every direction. So let me take this here. Every one of you is seeing this, right? And if I stand a little bit there, you're still seeing it. So I'm seeing here innumerable rays of light coming out, or else you won't see it. Now, given that it is blocked, it doesn't give light this way. But let us imagine it hovering in the middle of this space. Its irradiation is spherical. So it's sending light in every direction. Now, evidently, if I'm looking at this, I can't even begin to tell how many rays of light are coming from it and entering into my eye, right? So I have now a problem. Okay, I have the cone, but how does this yield to me seeing? If we look here at A and B in the right side, right, I simplified it. Let us take by hypothesis that A and B describe a surface of sorts that is between a stretch from A to point B. But I don't want to look at the entirety of the surface. I want to look at illuminated point A and illuminated point B on that surface. by randomness. From A, there are innumerable rays of light coming out, and from B, innumerable rays of light coming out. All of these rays of light are descending on the outer surface of the eye. Evidently, the outer surface of the eye is very small, but it is not so small that it doesn't receive a very large number of rays of light. And yet, I'm not confusing A with B. I'm not confusing this chair with that chair, or the gentleman here with the light in the ceiling. So there is something still organized in the way these rays of light are entering into the eye. And he says that the only ones that count are the ones that descend in a perpendicular way on the outer surface of the eye. And out of all of these rays of light, we know that only one ray of light descends orthogonally on the outer surface of the eye, and it would be the ray of light that hypothetically connects A with the center of the eye, O. So now, within the cone structure, there is only one ray from innumerable rays that counts. It is the one that comes at an orthogonal or perpendicular onto the eye, the outer surface. He has to do something here. وهذه صورة العينين أصحاب التشريح في كتب التشريح. He's not an anatomist. So he relies on the books of anatomy that were available and extensive tradition of dissection of the eye, evidently not human eye. Yeah, not human. And he tells us that it is all spherical surfaces until it reaches something very important, which is here. I don't want to go to the full detail. It's a lens inside, which is the crystalline. Okay, crystalline. I just want to stop a little bit with it because it is an interesting feature in the eye. All the outer surfaces of the eye are sections of the sphere. Yeah, and they are all organized in a way that they have one center, which is the center of the eye. Yeah, this means that the ray of light that is coming perpendicular onto these surfaces, by its nature, given that it is descending as perpendicular, it does not reflect or refract, according to him. It does not reflect or refract. It continues, pierces through the eye. It goes in. And it goes in until it hits the crystalline. So this model is, what I've drawn here is a simplified version. It has to tend towards the center of the eye. But it hits the crystalline and it has this kind of effect. The crystalline has this curvature that follows the spherical curvature of the outer layers of the eye. This one is inversely. Yeah? So these rays of light are coming direct, they pierce through it. Here, they do not continue, they refract. They change direction. If they don't change direction, we have what is called later on al-qumra al-muzlima, camera obscura. If there isn't that lens and refraction, you would have seen each other all inverted. Okay? But he says, no, there's no inversion. This model is so important because this is the model of camera obscura that has a dioptrics element, lens of salt, placed in it and subjected. Professor of physics who did camera obscura and dioptrics instrument and subjected to light for an aperture. More important in Trinity College, but using rather than spherical kind of instrument, using a prism. These are Newton. Yeah? Newton's, the entirety of the experiment of Newton is embodied already in the very structure of the eye. And I'll talk a bit later about this aspect. So I just wanted to give you highlights onto this because he's using now geometry as combined with his understanding of the behavior of light to explain how vision occurs. Now, behavior of light has a very interesting feature to it. He wants to show us. Just click one, please. Okay. So he does experiments of different levels of computation, from the very basic observation to the ones that require constructing an experimental space. So I said first, he's saying vision. Now we understand how it occurs. But now I need to understand the conditions under which vision can yield reliable observation. A reliable observation cannot occur just in randomness in space like this. I need a controlled environment. And the controlled environment is what he calls under the term al-i'tibar. This is the term used technically for experimentation. So for instance, if I have a candle and I'm seeing light coming from it into my eye, he says that light is traversing the space between the candle and the eye in a straight line. Right? But this is a statement that geometry suggests. Experimentally, what would you do if you have a candle and you're standing here and looking at it and you want to prove that there is a straight line from the tip of the candle to your eye? What would be a very basic experiment that you will do through a little instrument? If I have a small piece of paper, what will I do? I roll it, right? I'll make a little tube. He constructs a tube, and he puts a little piece at the end of the tube and shows that to himself that each time he closes the tube, he no longer sees the candle. It's a very, very narrow. So this is a very basic kind of observation. Another one, he starts constructing, he's an architect, he starts constructing installation. So he would say, okay, direct light comes from a self-luminous entity. So the fire of the candle, the light that is coming from the sun, from a fire that I lit somewhere. This is self-luminous object. It tends to be primary light. This light goes in the ambient, transparent environment between the eye and the object of vision in straight line. Right? But what about what I'm seeing most of the time? I'm not self-luminous. None of us is self-luminous. These are seemingly self-luminous. Okay? So does the light coming from us behave in the same way as the light that is coming from self-luminous objects? He needs to explain that. Otherwise, most of what he's seeing around him, right, can no longer obey to the rules that he has used for understanding the nature of vision when applied to the case of something like a candle, sending direct light. So he does these experiments to demonstrate that, for instance, an illuminated wall like this one, the rays of light that are coming from an external self-luminous source, the sun, descending on point O, having a illumination that comes from point O that corresponds to a point R. And then he does various apertures to demonstrate how the shapes of the hole where the primary light is coming contributes to the illumination of an object within a dark room that leaves a trace similar to the shape from which the light has entered. So let me give you a more complex example. He does here two spaces, and he brings a block of wood. He has inside it a cut, like a small tunnel within the block of wood that is parallel to one of the edges of the block of wood, and the other one is inclined. Here they are expressed in a more exaggerated form. This one straight, this one inclined. And this space here corresponds to LMN. LMN is a surface that is illuminated by the sun, facing a dark room here, that has these holes in its wall. And he waits until the sun comes out to illuminate LMN fully, and it is describing a circle. And he designs this whole installation in proportions that entail that if there is a direct sunlight descending on it around noontime, it will issue forth light that passes through these apertures that illuminates in a way that leaves the traces on the back of this wall as circle. So he proves to the eye that the surface that is illuminated is sending light out in a way that obeys the same principle as a candle would send light out, meaning the light is going in a straight line. But what is of importance is that he uses geometry to understand the structure of how to construct the experimental space of the installations that he needs in order to make this kind of observation. So this is just an example of the complexity of the experiments that he is using to demonstrate how light behaves and how this connects to various shapes and the effect that light has onto them. I did some experiments during the lockdown in my own home. It was here, it's in a space in Durham, in the north of England. I played around. But one of the examples that he said is that color behaves in such a way that it is irradiating, similar to the irradiation of rays of light that are coming from illuminated surfaces. So color moves in the space between the eyes of the observer and the object of vision in a straight line in similar way, like the rays of light coming from the object of vision into the eye, or the rays of light coming from a primary source of light, such as color. And all it took is to place these as being illuminated by a self-luminous object, which is the sun outside my studio, coming onto the colored objects. Look what the colored objects are issuing for. So the color itself traverses in the same fashion as secondary light that is coming from illuminated source. He does experiments further to that in terms of showing. So, for instance, if there's a dark room and I have a single hole in it, and I carry 3 lamps, Panadil, right? And there's different colors of the glass. He puts different colors of glass. And he puts the Panadil facing that aperture. He sees inside the room a correspondence of the red, let's say green and yellow. So these rays of light are coming and intersecting with one another, but they don't affect each other. So that's another observation that only an experiment can yield, and a geometric structure does not explain. So now what he has done is that he's controlling now the context of vision. Vision becomes reliable as a source for veridical knowledge when it is done in the context of a controlled environment of experimental testing. What does this suggest to you? This is not just experimenting. This is not just empirical inclination and thinking. This is saying to you now, only in the context of a controlled, repeated testing, that reliability of the information that is yielded can be ascertained. And in such a way that it is, I said, repeated, whereby I'm isolating the variables, and by changing their parameters, I'm yielding different observations. Now, vision can yield veridical observational data in the context of the controlled testing experimentally. But the experiment itself is not just a mere exercise that is empirical, it is structured also mathematically. Now he proposes something greater than, to my mind, than experimentation, he's proposing to mathematize physics. He talks about a leap between mathematics and physics. So without mathematizing physics and its notions, we cannot engage in experimental testing, control testing that is repeated, that yields vertical observational. And I said this to the group that is running a project between Durham, Oxford, and York around Robert Gross test, the Bishop of Lincoln. Usually historians of science say experimentation starts there. I engaged for 4 years, worked closely with them on Gross test. The entire group now, after being exposed to Ibraham, are almost on the verge of saying, okay, we are so happy that we've done Gross test, but this is where the work should have been done. And this is where the heavy mathematics have been invested. And it wasn't a group of philologists, historians, and humanists, people of the letters and adab, as physicists, cognitive science applied in the context of experimental laboratories of vision in Oxford, physics professor that were involved in this. And I mentioned one experiment done on parallax phenomena. We did it through ray tracing software. Another experiment that I don't want to go into great detail into it, but how he builds on the finding of his predecessor, Ibn Sahl, because Ibn Sahl stumbles on something, and this is where it's a remarkable work done by Professor Rushd, who demonstrates to us that Snell's law, for those of you who are exposed to physics, it's the basis for calculating diffraction. So these are in need of that kind of science. Snell's law is in the same configuration of determining the index of refraction. How light, when it comes from a transparent medium, passes into another transparent medium, the difference in density changes direction. Okay? This is all it is. But we need to know how to compute it. We need trigonometry. Okay? And this is Ibn Sahl. Ibn Haytham uses the formula of Ibn Sahl to understand more complex experiments. This is just a cross-section of another experiment. He wants to see in his own eyes how light is going to change direction when it passes from air into water. So he does a big dark room, and he places in the big dark room a basin of water. One of its sides is glass. Okay, so he could see the water with his own eyes. And he places in it a cylinder, immerses it in the water. And the cylinder has an aperture, a hole in the cylinder, where light is controlled where it enters. When the aperture is at point X, there is light coming from point X. He looks at the basin, he sees the light coming straight. He shifts it a little bit, places the candle and aperture at point O, the light is sent here, look at that, changes direction. He sees it in his own eyes. He knows the geometry, he knows the principle, he's not satisfied with that. He wants a controlled testing experiment based on geometrical structuring to see in his own eyes the behavior of light as it passes from a subtle medium such as air into a dense medium, transparent medium such as. And this applies to the way light changes in direction as it passes from the fluid in the crystalline lens into the fluid in the vitreous part, which is another fluid behind the crystalline lens. Now, some of the applications of the study that he's doing relate to spherics. So he wants to study, after all, I said the eye is constituted of sections that are part of the sphere. So one of the aspects that he needs to understand is to apply it to spherics, understanding of light to spherics. He applies it to a more complex system, which is conics. And this is a tradition that lasts till the 19th century in terms of using of conics for perfection of lenses. This is conical sections. not spherical, right? But the sphere suggests things that are applicable not only in understanding the structure of vision, but look at this. This picture, I'm bringing it from the geometry of René Descartes. Look at those. This is my analysis, what I find in the heaven. When is Descartes? When is Descartes? Let's tell you. Timeline. Which century? René Descartes. Okay, and we're separated by over 600 years from the time of Ibraham. All right, and this is Geometry of René Descartes. And when we talk about Cartesianism, we're talking about the beginnings of early modernity. So this is still applied to the case of exaggerating a single rain droplet to explain a phenomenon that is what? Rainbow. Right? Now, this comes from a tradition of commentary on Ibn Haytham that we find with Kamaluddin Farisi. There's a continuation, and it continues up to the 16th century with Taqiyuddin Ibn Ma'ruf, the famous astronomer in the Ottoman court. So the applications of spherics are good for understanding the behavior of light when it is applied to understanding the nature of vision and structure of the eye, but also it can go to meteorology, to the explanation of how a rainbow arises. Right? Now it's getting very serious because the rainbow is suggesting to us what? A phenomenon of coloration, color spectrum, right? Color spectrum arising in nature out of the double reflection and double reflection of light as it passes through rain droplets that are nearing the sphere in terms of their shape, nearly a sphere, right? So now if I combine this kind of application to what I showed you as camera obscura phenomenon with a lens subjected to light, and I put them together, I'm getting something very seriously close enough to the experiment in Trinity College by Newton, where the only change is ultimately moving from conics and spherics to geometric shapes that are unlikely to be stumbled upon in the prism. And out of the prism, what issues forth when Newton puts it in the dark room and light descends on it? What comes out of the white light? Rainbow, right? Spectrum of color. Yes? Which is a decomposition of white light. And this is something that we see in the reflections of Ibn Haytham. Let me stop now with it and take it now beyond the application of physics over the application of mathematics over physics in terms of understanding phenomena as complex as vision itself, or meteorology, or the context of applying them in experimentation. Let us now take it further, and this is where comes his book 3. Book 3 contains the treatise, to my mind, that is cognitive science. Cognitive. So now we saw light is coming into the eyes, right? It passes in such a way that it doesn't invert the image of the object. You know the principle that governs how light is entering into the eye. Light, to his mind, is constituted of extremely small particles that move at an exceedingly high velocity, right? And that leave a sensation in the nervous system of the eyes that is a little bit like pain, soft pain. Why is this the case? Because if I look at the sun, what will happen to my eyes? Strain, right? Sometimes when we're looking at our mobile in the middle of the night, and then you close the screen, you still see a little bit of the impress of that. Okay? So if there is a sensation of sorts that is left on the optical nerves in the back cavity of the eye, it is something like a little pain. There's in the system, in each eye, there's an optic nerve to his mind, in the anatomy of the eye and the optic system, they converge and they take the sensation to this part of the brain, frontal part of the brain. He calls it al-hasul akhir, al-has al-akhir, the last sentence. Up to this point, it's a physical phenomenon of light, leaving an impress on the physiology of the eye and its optic system, nervous system. Reaches the brain. Now, from this point onwards, it's the role of imagination, memory, discernment, and syllogism, some form of logical analysis that we do in a fraction of a moment. There's nothing in this moment that I cannot name, right? Even if I don't know any of the entities with exactness, I know that this is an object there that is technical object of sorts, tripod with a camera, some kind of writing on the wall. We have human beings, chair. There's nothing here that cannot be categorized. There is a single thing that cannot be categorized. I bet we are going to be in a panic beyond the description. Because it's going to be a phenomenon that our brain cannot process, right? So for him, we see visible meanings. He calls them literally ma'ani mubsara, intentional visible meanings, which means that what I see is already classified in such a way that it has become recognized, even if it is not recognized as an individual entity, it belongs to a class or a kind, nawa. Now, besides that kind of cognitive analysis, he wants to go into details. So I see the distance between me and an object of vision. That distance between me and the chair. Wherever I'm going, I'm carrying my perspective with me. My distance between here and the chair, none of you has the same kind of relationship. I'm standing here and looking at the chair. All of you are looking in different directions. That relationship between my eyes and this particular object of vision that I'm focusing on has a particular distance. Looking from this side, you could see this distance. It can be by surveying measure, because I could measure from here to there. I could do some kind of operation in geometry that I could survey this. But for me, in the intimate aspect of the immediacy of experience, do I see it? And how do I see it for short term? This is a problem that preoccupies later philosophy up to the 20th century. There's a philosopher very famous in France called Merleau-Ponty. He has a whole treatise on phenomenology of human perception. Over 50 pages is just about what he calls in French profondeur, which is the distance between the eyes of the observer and a given object of vision. This is mind. Even if you come and stand here, it's not going to be exactly the same. It can be approximated. But he's concerned with it. How do I deal with it? How do I judge this distance? So he constructs this experimental setting. Here, it's a space, it takes an object, and it's controlled environment. Here, it's a space where the experimental observers could enter. There's a wall separating them and an aperture. You don't see the floor, you don't see the ceiling. You just see object. Now he manipulates the light inside the space. Sometimes W1, this screen, appears to be closer to the observer than W2, which is the case. Yeah, which is the case. In other cases, he changes the light, and W2 appears to be closer than W1 to the observer. In other cases, he manipulates color, W2 and W1, and illumination, W2 and W1 appear as one surface. Now, W1 and W2, for them to be, whether he changes the light or the color, for them to appear to be where they are in that space, you need to see the floor. So he comes to the conclusion that I detect and understand distance between me and objects of vision if I have a common contiguous ground of objects between me and the object of me. Otherwise, whatever I do, I'm prone to some form of error in judging the distance. And by error in judging the distance, I have an error in judging size. So this is an experiment that is called the Ames home, 1950s. Now, imagine that I remove these two human figures and I put two cylinders, one orange and one yellow. And you look into the room, you see a huge orange cylinder and a huge, a small yellow cylinder. You look through the aperture and say, okay, that's solar, yeah, nice. What are we going to do with that? Okay. But when you look through the aperture and you see this, what are you going to immediately say? This is intentional, ma'ani mubsara, right? So immediately, there's no way there's two humans like that. Are you trying to trick me? There's something odd about this place. What is odd? Look at it. See, structure that has the back space, the back wall, is not parallel to the wall that has the people, right? Look at that corner. That corner is way far than this corner. And it has a height much more than this corner. And it gives you this optical illusion. The only way for you to detect the optical illusion is to remove this wall. And then you see the manipulation of ceiling, floor, and backward. And I'm talking about 1950s, where all of these implications of floor, ceiling, to determine distance and height. And again, here it's not a pure application of mathematized physics or experiment that is just relying on description through geometrical means of how vision occurs. It is a description of a cognitive science experiment. And again, I'm finding it in the optics of Ibraham. The tradition continues. I don't want to go too far, but the Franciscan College in Oxford, as it starts, it's full of opticians. And one of the main opticians is Roger Bacon. I've done other talks just on Roger Bacon himself, where Ibn Haytham is in the work of Bacon, okay, on perspectiva. So when they translate the book of optics of Ibn Haytham into Latin, they call it perspectiva. Sometimes they call it optica or optica thesaurus, right? But the main title is perspectiva. Perspectiva is in English now perspective. Perspective in Arabic is ilm al-manzur. Any architect, any interior designer, any fine arts, they have to know something about it, right? So Roger Bacon integrates many elements of the optics of Ibn Haytham in his work. And this is from the Franciscan tradition. It goes further into Theodoric of Freiburg. This is Dominican physicist. He integrates it, but he makes certain adjustments for understanding the implications of optics on meteorology. What is more important, and this is something else, who is going to the Warburg Institute? You're going, hopefully. Okay. I spoke just about perspectiva and art. So not in optics, but in art, in architecture, Renaissance architecture. You have Lorenzo Ghiberti designing the gates of paradise to the Baptisti in Firenze. He uses it's on every page he's quoting from the Vulgari or the vulgarization of the Latin version of Ibn Haytham optics, which is translated into Italian. So this is the basis of understanding perspective when I'm projecting it in a way that indicates the observer. Because imagine this as a painting that is hanging somewhere or as a fresco on a wall. As an observer, you never face it at the same level where all of these lines converge. You're doing this. So it's fictional position of the painter's eye in the projection that is used to describe something as accurate as a photograph, right? These are perfected perspectives. But when I place them in the observational context as an observer, usually doing this. So there's no matching between the point of convergence of the painting and my head. These are two traditions that build on Ibn Haytham. One, which is geometric optics. It builds the structure of the cone. So the cone of vision now, because I see in two eyes, but I don't see double, I assume as if instead of having two cones, I have one cone, and it is coming from the last standpoint here. So this is the eye of the observer. And those trained in architecture or exposed to any of this have to assume in a single point perspective as if you are abstracting that you have two eyes or using one. There you use as if it's a cone, but the cone is it's something like this. Look at the cone of vision, and if you put a screen intersects with it, you get this by projection. But this is not enough. That's where this other tradition, which is the tradition of Hiberti, uses Ibn Haytham to say, okay, there's geometric structure to vision, there's also cognitive. If I take into account the cognitive aspect, I have to take into account how I see things as a moving observer. I move, my head turns, my eyes are hovering. I'm not looking just like this. If I look even at the chair now, you might think something happened to me. If my eyes are not moving. So he takes into account that in terms of inverting, almost giving a curvature to the surface on which the perspective is projected. This is just to give you an idea of the extension of this. Some of the experiments of Ibn Haytham here are reproduced in a treatise called Opticorum, and this is a Jesuit school of mathematics in Antwerp, and it has architects involved in it. So this is just to give you a hint of the continuation of this tradition, and we're talking here about 17th century already. And you recall when I said, that kind of aperture and the light coming from the candle, this is the parallax that we did ray tracing, but here it is done through threads of line connecting to the point where you're looking through the eye and what you see. And here I found it quite remarkable. These are muses. Each time you see this figure, evidently that figure is alone. He's the scientist, he's the person doing the experiment. These are Banatul Afkar, right? His muses, the ideas, inspiring him. He's like thinking. Look here. One side, they are fixated on dissecting the eye. See? And when they're focusing so much on dissecting the eye, they're focusing on how light is entering and how it behaves and how it's the optic nerve, etc. And there's one here, which I find it so beautifully done. Say to them, no, you're just, okay, wonderful what you're doing, but without the brain here and the functions of the faculties, you don't see. Even if the light is entering in the most proper way. There's a treatise on mental illness, it's well known, like Sack, called The Man Who Mistook His Wife for a Hat. Man who mistook his wife for a hat. To give you an idea that vision is a cognitive process. It's not just the physical impress on optic nerve and physiology of the eye and on the neurological aspects of how it works, but it has translation into something that belongs to some form of cognition. And he calls it, yes, there is, yes, exactly. Perception involves the visual attestation of the intended meaning. Yes, visual perception. Yes. While vision here it's soft. So not vision in the mystical tradition, right? And I stress again, there's not a single use of nur. Yeah? So, okay? So, so these are 17th century beautiful by Rubens. Those of you who are in fine art, this is like one of the greatest Baroque artists doing the renditions. Another treatise, just to give you an idea of the continuation of this project. We have here Galileo, right? And this is the treatise on selenographia. Selenography is the study of the moon. So Galileo is the same age in the 17th century as Johannes Hevelius. And this is in Gdańsk, Poland, the Lithuanian Polish Commonwealth at the time, 17th century. Look what it places me. Actually, it's small, different here. Al-Hasan. He's standing on Versioni, holding a compass and geometry computer. Galileo is standing on sensor, an instrument that would not have developed without the science that this chap is holding here. And here he's celebrating Galileo. We're no longer in the cosmology of Aristotle. We're already in the heliocentric world, modern science, early modern science. When they say, you know, les modernes et les anciens, they say the moderns and the ancients. They look down on the ancients in the 17th century, never on a figure like this. And it's not me just making the story, frontispiece of the treatment. 17th century. Just the dawn of the coming of the age of Newton and the beginning of a physics that still, you know, is, you know, here, this space sciences center is here. And thank you. ايه بالعربي طبعا طبعا. You want it? Yeah.
بس كنت فأصبح أنت يعني دي اللوحة مو منظرها بس بطريقة جميلة وخلاص يعني قام عليه، فيها دقة متناهية. يعني الابتسامة للحسن سوري للموناليزا نفسها هي التي تسمع. يعني ابتسامتها يعني أنت تشوف يعني ابتسامتها من كل الاتجاهات. يقال أن الدقة التي يعني تميز بها دافنشي تعود للتداعي به على كتاب الحسن البصري. فهذا يدل بعد أن ما في إشكال نحن ناخذ من الحضارة يعني نكمل بعضنا البعض، لكن فعلا لعلمائنا المسلمين دور كبير في الحضارة يعني خاصة ما بعد الحروب الصليبية إلى وقتنا هذا يعني الحضارة جذورها إسلامية. نحن لا نتقدر، نحن نكمل بعضنا البعض. شكرا جزيلا على
بس تعقيبا على هالتعليق، كتاب المناظر ترجم إلى عدة نسخ بالمخطوطات اللاتينية، أتت معظمها من توليدو. الأرجح جيرارو في كريمانا هو حلقة المترجمين، ولكن هنالك خط آخر قد أتى عن طريق ساليرنو في جنوب إيطاليا، ترجم إلى اللغات الأوروبية حتى، وكان متوفر باللغة الإيطالية لجيل يعني من العديدين من الفنانين مثل ليون باتيستا ألبرتي، لورينزو جيبرتي ومن كتب عنهم، حتى وصل إلى مرحلة متقدمة من استخدام المنظور بإطار عصر النهضة الإيطالي. فتوفر المعلومات كان مش فقط مقتصر على أماكن تخزينها في المكتبات، ولكن كان هو جزء فنانين هنا حول قضايا المنظور وعلاقتها بعلم المناظر. وابن الهيثم كان متوفر بشكل واسع، ونحن لدينا يعني من منطلق التاريخي هنالك إشارات لأنه كيف تلقفوا كريستيان هيجنز أو نيوتن أو غاليليو. ولكن الحلقة على المستوى التاريخي التي تربط ما بين كتاب ابن الهيثم ودافنشي هي غير موجودة بشكل موثق، بمعنى أننا لا نستطيع أن نشير إليها إلا مواربة. يعني تفضلت فيه هو دقيق جدا، لأنه لا يمكن أن نرى هذه الابتسامة بدون أن يكون هنالك أو تأطير بنيوي لفهم عميق جدا لكيفية تواتر الضوء من النقطة التي ننظر إليها إلى عدة اتجاهات. والأخذ بعين الاعتبار، وهنا الأهم ما أشرت إليه بالنسبة للورينزو لما حطيت اللوحة اللي هي مذهبة، أنه أخذ بعين الاعتبار كل حركة العنق، أشخاص من عدة قامات وعدة جهات ينظرون إلى المنظور. فكل هذا متوفر. لورينزو كل صفحة على المانuscript الإيطالي، كل صفحة الحازن، وعندما يريد أن يتصارع معه يأتي بابن سينا. أيوة، يأتي بأسماء من الحضارة التي هي بالنسبة له هو جزء من حضارته يعني نوعا ما. وهون اللي أردت أن أضيفه، ولكن ربما أشير إليه لاحقا. لقد شددت منذ البداية أن العلماء من المسلمين والعرب، وأقول عرب لأن هنالك صابئة بينهم ويهود ويعاقبة ونصاطرة ومسيحيين ومن كل هذه التوجهات وسريان وعدة لغات، تلقفوا هذا الإرث الإغريقي على أنه هو لهم. عندما يتكلموا عن أفلاطون أو عن سقراط يتكلموا على كأنهم من حكمائهم. ولكني ذكرت بأن هنالك ردة فعل أتت نتيجة استراعات سياسية ربما. مثلا عندما نأخذ المعتزلة لم ينطلقوا بشكل كامل وراء بعض التوجهات الفلسفية عند الإغريق، ولكنهم ارتكزوا إلى المدرسة الذرية عند الإغريق، ديموكريتوس. استخدموها ضد من قالوا عنهم بأنهم حكماء المشائية، بريباتيك، أي أنه صراع مع الأرسطوطالية وليس صراع مع الإغريق بشكل عام. وهذا في صلب علم الكلام. والمحنة التي أتت للإمام ابن حنبل هي أتت من إطار التفاعل الجدلي والاصطراعي مع الفكر الإغريقي. فبالتالي هذا الفكر دخل في باطنة الحضارة الإسلامية، وعندما صار ذلك النقل إلى الإطار الأوروبي لم يستطيعوا الوصول إلى الفكر الإغريقي إلا عبر ما أتى من إثراء من قبل الحضارة العربية والإسلامية، ولكن ارتكزوا في وقت طويل على آراء ابن رشد وابن سينا وابن الهيثم أكثر من ارتكازهم على أرسطوطالس أو أفلاطون. المرجعية كانت في كثير من الأحيان تعود إلى هؤلاء العلماء أو الحكماء وليس إلى الإغريق. وهيباليوس عندما يكرم ابن الهيثم، إرث الإغريق أصبح في الخلف تماما. نحن تخطينا الآن أرسطو وبطلميوس وجيلن، دخلنا في أفق الحداثة المبكرة، ولكن بقي لأنه طريقة تفكيره experimental science, mathematizing physics, cognitive aspects that are behind the truth conditioning of what I take to be observational data.
Thank you very much. Very lively lecture. This is your science. Going back from optics to philosophy again.
Beautiful.
My mind from reference to Ibraham. As you know, usually they say that they are collecting many ideas, from different philosophers and scientists and so on. But when I read it, it appears to me very original. There are, of course, types of originality. Yes, we all borrow from other previous scientists and thinkers. The problem is, how to put that into a systematic form. This is their achievement.
Sure.
And this should be appreciated actually. The only thing that comes to my mind is what I wonder, how come it didn't have any influence on later Islamic thought? Or is it there is something that is very limited that I cannot see? This is what I was just wondering.
It had influence on حكماء المسلمين. Even in early, at early age, it was read, the Rasail were read in the house of Ibn Sina, right? With his father. But the level of the material that is contained in the Rasail is aimed at educating. So it is not presenting the highest forms of the most complex, let's say, handling of numbers. So there's no algebra in the treatise. There's more basic form of arithmetic, and it is more for number reckoning, particularly for accounting purposes. But it is still, what is important about it is that it signals that unifying structure, that it is not a scattering of influences, but seeing within them a unifying kind of thread that is articulated around mathematics and numbers in particular. So that's one side. Now, sometimes they tie them to the Ismailis, but it is not as themselves being of the Ismaili tradition. But the du'at of the Ismailis build a lot of their system of thinking on quotations or elements from the Rasail. And in the European tradition, parts of it survive in more mystical or occult sciences, particularly in the Yiddish traditions. So Hebraic Jewish traditions that assimilates element from the Rasail. But they get quoted, but in a scattered way. Ibn al-Haytham himself, if we think about the position that he occupied in the Islamicate and Arabic civilization, it's not as prominently visible as we see it in the European milieu. In the European milieu, he's embedded in this very structure and fabric of many schools of thought. And I mentioned, Franciscans at the founding of Oxford, the Franciscan College, the tradition of the Dominicans in Germany, and the traditions of the Jesuits in Belgium, and all in the circles of opticians, architects, mathematicians, up to Lithuania and Poland in astronomy. So, and evidently also in the arts of the Renaissance. We see the same with the case of Ibn Sina. If we put it on par, Ibn Sina, a whole foundation of work is established in the Muslim world upon as-Sinawiyya. I would say, both of us engaged in a different trajectory with the tradition. I called for Sinawiyya محدثة بانعطافها في التفكير تتفاعل مع ميتافيزيكا هايدغر. يعني ابن سينا لا زال حي فكريا. His influence is very, very visible across the philosophical spectrum in the Muslim world. While this is not the case with Ikhwan al-Safa, nor with Ibn al-Haytham. Ibn al-Haytham, it's the school of Maragha because of Qutb-ud-Din al-Shirazi bringing the treatise to Kamal al-Din al-Farisi. But we don't see further prolongations, but further commentaries that fall in the hands of a figure like Taqiyuddin ibn Ma'ruf, a Syrian astronomer, but in the Ottoman court. Yeah.
First of all, thank you for your brilliant lecture. I want to add some remarks. There will be no questions. As from the psychological perspective, as you, in the beginning of your lecture, you talked about psychosomatic aspects and causes.
Yes.
And as you, as your lecture delivered, the lecture actually about observation level and as a science, psychology, science and psychology, the main source of psychology is observation. So if to talk about Islamic psychology, so your lecture actually directly relates to the beginning of psychology of Islamic civilization. So thank you very much.
Thank you. Thank you. Thank you.
Thank you, sir. Thank you for your wonderful presentation regarding the observation of things. My doubt is, if one object is in front of us, can we share, suppose we have 20 or 30%, shall we seeing that object in different way?
This is where issue of visual perception and the psychology of vision figures in there. And this is now at the heart of the most advanced forms of analytic philosophy engagement with consciousness. Actually, there's a beautiful lecture by Hilary Putnam. I had the privilege to be trained under Hilary Putnam. And he said it triggered a whole book for him, you know, this naive realism tendency and in analytic philosophy. He was on the beach and he was looking at a wall and looking from, you know, the right eye closer to the sand and the left eye, you know, higher from the sand, and closed one and opened the other, kept on playing with this and noticed that the whiteness of the wall has varied, right? And from this, he even went to the point of thinking not only about that difference in perception between an observer and another, but ourselves in the very immediacy of the experience, how it varies under the conditions of the healthiness of the two eyes, perhaps, but also the what we know in more modern form, the differences that come in terms of, you know, us seeing from right side and left side, and under conditions in which we are not in an upright position. So there is differences also in the angle of vision, even if it's minuscule, that would have figured in that, right? And he has a whole lecture just on this. Now, how do I tie it to Ibn Haytham? Yeah, well, evidently, if I'm looking at this, I'm saying ma'ani mubsara, right? Now, in this situation, we could all have descriptions that we could all agree upon. But this is where I find him fascinating, and this is where psychology kicks in, is that the experimenter, even under the most controlled testing, right? If we leave it with one experimenter and not repeatedly doing it, we might mistake the conditions of the controlled test to be valid. But what if I'm today unwell a bit? What if I'm a little bit preoccupied somewhere else? What if my observation is not very accurate? I repeat it. But should I need someone else to look? Yes. And this is where I find him fascinating, right? There is accountability. Fudging your data. Like some of you are scientists, right? Here, fudging the data. Yeah, you need You need a team somehow, no? And this is where I find the issue of difference occurring, but also there is the psychological aspect. Now, let me do a bit of phenomenology almost, yeah? I'm holding it. It has a certain value different than me holding it tonight, not it, but something like it when I'm a bit thirsty at home, rethinking about what I said and didn't say in the lecture, versus now I'm telling you something about it and I'm taking it as an example for visual perception that I have a vested interest intentionally, right? Ma'na, intentional, that I really desperately need to drink. Now I want to, right? So that kind of relationship that I have with it is not strictly visual, it's psychosomatic, we said. And he's aware of those. But he knows that there are certain limitations that beyond which all I need is to vary observers. Yeah. So I could be in this relationship different than when it was here. It was in my visual field, but it didn't become an element of focus. And you told me about that, not this. And I gravitated to this. All of these dimensions are not based on controlled circumstance in which I'm commenting on a phenomenon happening under your eyes now. So my observations about this are fuzzy. Yeah, yes. And maybe someone who has never seen these will be like, you know, wow, lamps. They give a little bit of light. I don't know. What are these things? But they're not going to be startled and scared. But if we see a phenomenon that cannot be named whatsoever, there's no way we're going to be like standing, oh, wow, wonderful. My brain cannot fathom anything about it. Yeah. Or a big category of kind of sort. There was a video, actually, I don't know if it happened or not. It was before I came to to Sharjah. It was 3 months ago. No, sorry, in the summer. The Museum of the Future in Dubai. There was a video circulating on the internet about like a hovering kind of, not a drone, like small, but really a spaceship. And it came, and then the Museum of the Future opened and it descended. It's almost like something, you know, our grandchildren might see, right? And no one commented, no one said anything about the phenomenon. Now, the visual effects are so powerful that you could take it for, you know, as an attestation. In that circumstance, you're faced with all kinds of startled questions. If it is true, then this is really, you know, have we entered into an age that we haven't yet had the chance to see its first manifestations, right? It's really like, it takes you aback. But then when you don't hear lots of commentary that goes beyond the video, you just shrink a little bit from the startled effect. But imagine if we were standing there now, we were going for a tour to the near the Future Museum, and this happens in front of our eyes. I will be like, you know, I wouldn't say scared, but I'll be, what is this? Yeah. And yet I still could name it. I could say, this is amazing technology that I thought maybe in 30 years it will happen. But yet here it is. So, and think of a culture that is telling you fables and the jinn and the, right? And all the Rahalat Ibn Battuta, and you think of that culture against the background of a sober mind like him saying, my goodness, here and here I'm standing. I can't rely entirely on my observations.
Thank you. And if there are physicists and mathematicians from here who would like to work on that, okay, we have to work more on that. I want to do experiments in here. Yes.
Thank you very much. It's very nice. But one sadly has to notice that acknowledge the difference that it's not yet got into the physics courses. I only knew about Ibraham since I started to get into the Arabic culture. Whereas he was doing so great jobs. So, I mean, it's amazing. I tried to circumvent a little bit, but tell the students a little bit about what I knew at that time. But really, the physics books have to change also.
Yes.
And one has to sort of engage with this.
Yeah. Actually, this is a good forum to mention this. The interest now in the SIFHAMS tradition, I know it from fellows of the Royal Society already, but it needs some kind of partnerships that happen at high-level institutions, so that the full breadth of the tradition is accounted for in a way that is not restricted to a small group of highly seasoned scholars that secure a Royal Society grant and keep it within the mansions of the great institutions of Britain as an endeavor, but to spread it much more widely. And my dream is that, but I don't know, and one could dream that this university with its capabilities could put its weight behind this kind of endeavor. His oeuvre, I think, could involve 20 researchers from multiple disciplines for over 10 years, and yielding papers that could go into physics journals, cognitive science journals, and not only humanities. It should, but the first impact, and this is the issue, is that for the high-brow community of scientists to recognize. And I know now in the Royal Society it happened. I'm in communication with more than one fellow, but you can't leave it with a physics fellow of Royal Society. You need to have a whole infrastructure that re-embeds Ibn al-Haytham also in his Arabic media, or else it is Ibn al-Haytham going into the new chapter of a new Gerard of Cremona and becoming Europe's, I think partnerships should occur now. It's a beautiful time for coming around these legacies that bring multiple nations together in terms of their heritage. This is the Greek corpus, this is the Roman corpus, this is the Syriac corpus, this is the Arab, Muslim, Latin, European Renaissance, European early modernity, up to Newton. And we could celebrate a common heritage. And he's one example in that. One example.
It's also a way how, for instance, there could be a renaissance of classics.
Yeah.
Because right now, natural science is sort of rightly or less going into a direction which leaves all of this behind.
Yes.
Because there's so much new physics
for sure
that needs to be error and so on. But still, the basis needs to be put correct. So,
and it is not entirely just an exercise in history of science. I think there are elements here in the epistemology that I find them quite remarkable. Yes. Yeah. But let us put him first in textbooks in the Arab world also. And undergraduate or even school time. We come from the Lebanese system of education, they used to have تاريخ العلوم عند العرب, and we were exposed to this at the age of 13, 14. They removed it entirely. And they come to university barely speaking Arabic now, and you know, yeah. And I think most of our societies are facing similar. And another chapter which would be remarkable, and I wish will correspond, we'll talk about it. Into Arabic, the Principia, nearly 30 years after it came to print in Britain, translated in Arabic in India through the Persianate lineage in the Indian sciences, and treatises written that now we have entered into the new science through the Principia of Newton. So this shows also a remarkable new chapter also in the handling of science through the agency of the Arabic language in cultures that are in their very fabric non-Arab ethnically, but intellectually find their continuation as a civilization through the Arab language. And it's a remarkable area of research that needs to be unearthed, because it contributes also to reconsidering all the colonialist practices of the British at the time, in the way they looked at, in some aspects, at the science in India at the time of the East India Company as being a science that is not with the age. It's a total fiction. And now the scholars in Cambridge are making the rectification of this time. No, they were conversion commentators already on Newton, no less than their counterparts in
this topic, Professor, I was going to ask you, yes, Europe, Arabs, but the eastern part, we have to forget about. I spent almost 26 years last year. The East, Southeast Asia, China, India, everything there. And I saw amazing works written in Indian languages. And yet there is a huge need to understand, translate these works into our today's language, science.
Yeah.
There was a professor from Sweden. Ibraham was studying Indic manuscripts, and that the problem was that he could not expand himself in languages, or particularly Sanskrit. What is your advice, further advice? Similar thing goes to the I don't like the term China, neither the Chinese civilization, but I want to be on this thing. East Asian civilization, we call it. Then we include all the way from Vietnam, Cambodia, to Korea, Japan. With justice, because where are we? Where is West? Europe on this matter.
Very, very difficult question, but I like to operate within a little bit of my comfort zone. And my comfort zone is, and maybe I'm mistaken or not. I believe that there is a tradition that is Greek, Arabic, Latinate, that is totally intertwined, and without which we don't have even the concept of the West. And I think the very basis of early modernity, upon which not only European science, culture, and civilization, starts to arise, but also the New World, and the implications that this have, are very controversial in colonialism, eventually, and imperialism. But I think,
personally, I think we should work with what we have embedded in the actual texts as evidenced entanglements of tradition, because that will give us a basis upon which we could rectify certain mishaps or misunderstandings, and they could translate into a commonality of heritage that is far more complex than what we normally accept as being our own heritage. To take it to India, I think, from my own areas of engagement, it remains within the realm of the articulation of science and philosophy through the agency of the Arabic language, because this is what is a direct commentary tradition that connects with what we find even in the impress on even on the Ottoman court or in the Persianate world. And that is at least as a starting point, because what you suggested is an endeavor that requires whole nations, ministries and governments. But for scholarship, let us work with what we hold in our own hands. So for instance, I gave this example about India, just one example, which is the Principia of Newton. That to translate it into Arabic and start writing commentaries on it and celebrating the work, this by itself is a direct answer to the historiography of the British colonial presence in India. It's a rather than going to it through Foucault and cultural theory and critique and colonial studies and political theory only, go also from the side of showing the vitality of the tradition in that milieu. The same with the we think that it stopped. Okay, it stopped in certain forms. There's no more Ibn al-Haytham sitting next to Newton. And this is 18th century or 19th century, and Europe is forgetting. So now we have the Marx and Freud and Nietzsche, and right? That's forgetfulness. That's forgetfulness. And that's why I like a bit the Heideggerian tradition, because it goes to the pre-Socratics. That's where the answers to what we, even the atomic bomb age, the answer is pre-Socratic in the ontology. I think what we have as a direct encounter from my own perspective is that there's a Greco-Roman mind in the folds of the Muslim thought, and there's in the folds of European thought and the New World, the shaping of North America, USA, there's an Arabic Muslim mind, all in the folds.
I remember Professor Cosmology in 2009, we were sitting in a very nice cafe in Kuala Lumpur with a professor from Nader University in Australia, and there was a beautiful project about using Silk Road and intellectual transformation via Silk Road. How ideas were moving from one phase was not only trade, it was ideas mostly. But we don't focus on ideas, we focus on
trade.
Sorry, Professor.
Yeah.
Thank you very much. One thing I would like to add to what books in India. Public library is the college, one of the oldest library in Malabar region. So recently, I could see a lot of books in Arabic. The book includes all the branches of science. So in the stage of damage, I was taking into the research lab. One of my research scholar, he's from Yemen. He was saying that the original copy will not be the author of this book. That much old book we have. So we are ready to provide to wherever we need to utilize for.
Beautiful.
Very old books are there in the library.
Yes.
The most of the all genres of the science and branches are
Yes.
available. All
all the books are in Arabic itself. That's a
Yeah.
very important part.
Sure.
Nader, thank you very much.
Thank you.
Thank you.
Thank you.
Right
Right time. Yes.
I said 2 hours.
2 hours 15.
Thank you for your
Thank you.
great
Thank you.
presentation. Welcome to the family of SIFHAMS.
SIFHAMS. Oh, it's my privilege and pleasure.
International graduate into the school for this. We are concluding the third day, the second session of the third day.